All right, friends, welcome to 2.5's notes, completion on video. And look at this, we get into the good stuff now. Writing two-column proofs. Woo! So in the first couple sections of this chapter, we talked about deductive reasoning, logical reasoning, if this, then this, how can you flow? And in section 2.4, we talked about the properties of algebra. We're going to start to remind you of how you justify statements. Well, let's get into now constructing the actual proofs. So first off, what is a proof? There's a good definition: logical argument, deductive reasoning. There's no inductive guesswork with patterns. It's going to be foolproof and fact-based. We want to show a statement is true. So the two-column proof is the proof of choice for us in this book. There's a couple other ones that we'll talk about, but this is going to be the one that we ask you to do and to perform. All right, so let's see. This is the general setup of it, which I'm going to get to on the next page. The reasons used in a proof can be definitions or properties or postulates and theorems. Cool thing about a theorem, like Pythagorean theorem, we can actually prove it, whereas postulates you just accept as fact. A theorem can actually be proven, and we'll prove so many theorems throughout this year. Now, this page is important. It is the structure of a proof. You're going to have some diagram. Sometimes you won't, but most of the time you'll have a diagram, and then they're going to give you information about it and ask you to show something else. So watch how cool this is. The given information, and they're telling us that 1 is the same as 2 in this picture. So that is always going to be your first statement. So the structure of a two-column proof, you see the two columns. You got statements and reasons, and you number them, obviously. And we'll get into chapter 5 where there's like 12 steps. Sometimes there's only 2 or 3 steps, so that part varies. And the word given will always be your first reason. So you start out with whatever they gave you and your reason, because they gave it to me. It's given. We don't end the proof until what we were trying to prove is in our final step. All right? And there are so many different things that can be here to get us there. But the middle parts, that'll change based on what it is we're trying to show. So let's get into one here. Now in this chapter, I'm going to give you the statements as you build and practice towards writing these. In the future, you'll write the whole two-column thing by itself, but I'll have the setup for you, statements, reasons, and I just want you to practice justifying what's happening in this particular chapter. So our first statement is always what was given to us here. That's always here. Reason is given. So now think about what they're doing here. Now you step back and you look logically at it. All right, they're telling me that AC equals AB plus AB. All right, and if that's the case, they're saying that AB should be the same as BC. So that's why they didn't stop till they got that. So now how are we going to show it? Well, they walked you through it here with steps 2 and 3. All right, the second step comes at us with AB plus BC equals AC. Oh, well, what is that? What is that when we take one segment, add it to another to equal the whole entire thing? Well, I just kind of said it, right? When I'm adding segments, that is the segment addition postulate. Seg add post. All right? So you can write it all out. I like to abbreviate stuff. You could even put the SAP if you wanted to. Segment addition postulate. And again, anytime you take 2 little segments, add them to the bigger segment addition postulate. Now, what they do from step 2 to step 3. In this one, we have AB plus BC equals AC. Well, think about what happened to each side of the equation here. Let's see. AB plus AB, where did I see that before? Well, I saw that right there. That's the same as that. AB plus BC, let me color code it. That is the same as that. All right, well, think about what properties we had in the last section. If AC equals AB plus BC, and AC also equals this, then they put these two things together. Well, that's one of two things. You could call that the transitive property. The transitive property of equality. Or you could call it substitution. So this particular one has a couple different justifications. Property of equality. Again, they wanted to get, and we'll talk more about why they did this a little bit later in the next couple chapters, but essentially, if you want to get AB equal to BC, then you got to get AB and BC in the same equation. So in the first equation, we had AB, we didn't have BC. Second equation had a BC in it with AB. Now let's get them so that they can equal each other. So by setting them across from each other like this, now let's see, what can we do here? How do we go from AB plus AB to AB plus BC? Well, would they subtract on both sides of the equation? An AB. So they crossed them out or subtracted. So this is the subtraction property of equality. So you can see here that we're using postulates, properties to get to where we want to be. And that is the ultimate goal. All right, let's keep rolling here. In this situation, we have angle 1 is supplementary to angle 3. Angle 2 is supplementary to angle 3. So therefore, they're saying that 1 should be the same as 2. If they're supplementary to the same angle, then they should be equal to each other. So we got to make it look pretty. All right, so first reason is always given. And then next, let's see, what did they do? Oh, here's a good definition. How do you go from the word supplementary to the degrees of 180? If 1 is supplementary to 3, then 1 plus 3 is 180. If 2 is supplementary to 3, then 2 plus 3 is 180. That is by the definition of supplementary. Definition of supplementary tells us that the angles add up to 180. So if you replace the word supplementary with 180 degrees, then that is the definition of supplementary. All right, next. Now we got 1 plus 3. So to go from here to here, how did we do that? So 1 plus 3 equals 2 plus 3. Well, if each of these expressions equals 180, then they have to equal each other. And again, just like the last one, that is either substitution or the transitive property. You got 3 different elements here. You got this element, and this element. So 3 things. As soon as you see 3 things, you're thinking that's transitive. This one also could be done by substitution. And now we got 1 plus 3 equals 2 plus 3. So if I just cross out the 3's on both sides, I got 1 is 2. When you cross things out, you are subtracting from both sides. So there's a subtraction property of equality. And then this is just a little fancy thing here to go from the measure to the congruence, because we want it to be exactly like it is up there. The measure of the angles are equal, then that means they are congruent. So therefore, that is the definition of congruence. Again, that's one we're going to talk about in class, but now you have it on the video. If you just go from the equal sign to the congruent symbol, you drop the m's, the little tiny m's, the measure ofs. So that's definition of congruence. All right, see what you can do with this one. Pause the video here. We'll pick it back up. All right, so let's see what we got. So there's T is the midpoint of SU. T is the midpoint of SU. I don't even have to think about it. That's given, so that's my first reason. All right, now let's see where this is taking us. ST is congruent. Well, let's just make sense of it first. So T is the midpoint you want to solve. Prove that X is 5. You know what you would do. You would take these 2 expressions and put them equal to each other. All right? And so to do that, though, they're walking you through it with the actual step-by-steps here. So ST is congruent to TU. Yep, we know that. That's the definition of midpoint. The definition of midpoint allows us to set these 2 expressions equal to each other. All right? So then when I go back and forth between equality and congruence, this is a step that doesn't need to be done once we start writing our own. But for now, we're going to just play their little game here. So that's the definition of congruence again. Congruence allows you to go from the congruence symbol to the equal sign one way or another. Now, here's an important step. To go from ST to 7x and from TU to 3x plus 20, we'll look up here. So we got ST is that, TU is that. So what did we do? We substituted. We substituted in the expression. So substitution, property of equality. All right. Then, of course, how would you solve this then, guys? To go down from here to here, you would subtract 3 x's on both sides. So this step would be 4x equals 20. And that is the subtraction property of equality. And then the last step, you divide both sides by 4, right? To go from here to here. So there is your division property of equality. So that's a two-column proof. You're just stating the reasons of what allowed you to write all these things over there. All right. Next example, same thing, guys. It's two-column proofs. Given M is the midpoint, so first statement, M is the midpoint, first reason is given. So we know that M is the midpoint, so we know that's the same as that because it's given. They want to prove that AB, this whole thing, equals 2 of these, 2 AMs. So let's do it. First off, they are setting the two little segments equal to each other. And what allows you to do that, of course, is the definition of midpoint. That's what allows you to set that up. And then you can go the definition of congruence. You don't even really need that word. What you have here is you're switching from congruence to equality. Then we've got AM plus MB equals AB. So we've got this little segment plus this little segment equals the whole thing. So what do we call that, of course? That is your SAP, your segment addition postulate. Sig add post, SAP, however you want to write it. Moving along further here, how did we get from AM plus MB equals AB to AM plus AM equals MB? Well, this is a powerful statement. They're equal to each other, so anywhere you see an MB, you can substitute in an AM because AM is equal to MB. And now that we have AM and AM plus AM would be equal to 2 AMs. All right, and they're calling this distributive property, but I think it's a little bit nicer if we just call it simplifying. It's a little confusing. Or you could call it the combining like terms. But again, don't stop until you got that down there. All right. All right, try your last monitoring progress. Got lots of good stuff in this section. And let's see what we got here. Pause the video and we'll come back and unveil this. All right, so here we go. First, of course, is given. Don't even think about it. Just plug it in. And let's see here. We're given that MP bisects the angle. That should mean that we should be able to prove that 2 LMPs, LMP, 2 times that is equal to the big one, LMN. All right, makes sense. We should be able to. So how do we go from, what are we writing in here? LMP and MP, that is straight up definition of midpoint. I don't like that. Here's what we're going to do. We're going to call this, the book has their own ways to do things sometimes, but I like to try to make things a little easier for you guys. Whatever word they use in the given, I like to use that instead because technically that'll help you remember it better. Definition of bisect. Definition of bisect. All right. So that's really, because like if they would say it's the midpoint, then you can use midpoint. But like I said, I like to think about it as whatever word they use, then I want you to use. All right. And then again, here's that little transfer from congruence to equality. So there's definition of congruent. And then let's see what happens here. Then they go from LMP to NMP. Oh, that's a nice one. And again, we are taking LMP, this little angle, plus NMP, this little angle, and setting it equal to the whole big thing. So in this case, this is your, I think the book's whacked on this one. It had segment. This is your angle addition postulate, or your AAP. All right, and that's why this must, I don't know why they're writing segments, but this is angles here as well. We're dealing with angles, my friends. All right, so then how do we go from 4 to 5? Well, LMP plus NMP equals the whole thing. So again, I took a little angle, added it to the other little angle, equals to the whole big angle that's inside of it. And then they're going from step 4 to 5, LMP plus LMP. Oh, all right. Well, how are we doing that? What is allowing us? Well, since we said here that LMP equals NMP, anywhere I see one of them, I can substitute in for the other one. So there's a substitution property of equality. And now I can combine these two. So I'm going to call that simplifying. All right, guys. We're going to go through this slowly. We'll get there. I know it's a lot of information, but you will get it. I promise you. Every year it starts out tough, but you will get it. All right. Peace.